Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. My dear students, today we are going to discuss the Royal College paper which was conducted in the year of 2022 in the month of January, right? In the part 1 paper, the first question is, using the principle of mathematical induction, prove that summation r equals to 1 up to n r into 2 to the power r minus 1 equals to 1 plus n minus 1 into 2 to the power n for all n belongs to z plus. Okay, you all know, for solving these kind of mathematical induction question, what are the steps that you are getting? What are the steps that you are getting? You all know what are the steps. Let me remind you. First steps is, you have to take a least number that n can take in the set of z plus. In the set of z plus, what should be the least number? Please tell me, what should be the least number? Least number should be 1. Why? Because 1, 2, 3, and so on, that should be the z plus, all positive integers. So the least positive integer should be 1 in the z of z plus. Okay, so we have to take this problem and we have to make sure this problem is true for n equals to 1. So instead of r, this type of question, instead of r, I have to take n and I have to show this result is true for n equals to 1. That's why I am taking LHS side here. I am taking LHS side, I am checking whether it is true or false. So in the summation from r equals to 1 up to 1, here instead of n I put 1. Why? The least number that n can take, that is I am going to check, right? So some people inside the summation they put the values instead of r. They put n instead of r inside the summation. We can't put the values inside the summation. So apart from the summation, I have to make sure this part, it means this part has the same number when I put the values, right? Here we have r, so instead of r I put 1. Here also I have r, instead of r I put 1. So 1 into 2 to the power 1 minus 1. It means 1 into 2 to the power 0, 2 to the power 0. You all know whatever numbers with the power of 0, that should be equal to 1. So 1 into 1, that's equal to 1. Let's take RHS. In the RHS, we have n, right? So instead of n, we are gonna put 1. So 1 plus n minus 1 into 2 to the power n. So instead of n, I put 1. Here also I put 1. So 1 plus 1 minus 1 is equal to 0. If we multiply any number with 0, that should be equal to 0. So 1 plus 0 equal to 1. So LHS equal to RHS. Therefore, we can say this result is true for n equals to 1. What is the next step? I have to choose a random number in the set of z plus. That's a random that is going to be p. So now we are going to assume that the result means this result is true for np. For p belongs to z plus. The p is a random number in the set of z plus. What should be the random number? P, right? So we are taking this result is true for n equals to p. So summation r equals to 1 up to p, this result is true. So we can write the same as what we got here, right? Okay, so that should be summation r equals to 1 up to p, r into 2 to the power r minus 1 equals to 1 plus p minus 1 into 2 to the power p. Okay, so this is, we have to find the solution of the principle of mathematical questions. So I am taking this as a true. This is my assumption, right? Suppose we are going to take the supposition of that. So step 3, what should be the step 3? Tell me. Now we are going to consider n equals to p plus 1. What should be the p plus 1 number? P plus 1 is the next number of p, right? So if I can show the result is true for n equal to p plus 1, then I can say this result is true for all n belongs to Z plus. Now consider n equals to p plus 1. So take LHS site summation r equals to 1 up to p plus 1. Now we are having p plus 1. Before that we got this result is true up to p. Now I am putting p plus 1. I am checking whether this is true or false. Even p plus 1, right? So inside the summation, the same general term I have r into 2 to the power r minus 1. You all know if we have a summation up to p plus 1, then I can divide the summation into 2 parts. If I can make the summation up to p, then I can put the values of p plus 1 in the general term. Why? Now I am taking the summation up to p. So here is the summation that we have up to p plus 1. Then I can put here p plus 1. Why? Inside the summation, instead of general term, I can put p plus 1. Why? Because this summation is calculated up to p plus 1. Now I made the summation up to p. So if it is equal to this part, right, I want to make sure these two are same. So for solving these two are same, then I make the summation up to p. Then I can put the term p plus 1 instead of this general term. So consider this part. This is what we have instead of this, because we have found this from my supposition, from my assumption, right? So instead of this part I can put this. Now if we put the values p plus 1 into 2 to the power p plus 1 minus 1, plus 1 minus 1 cancel, I have 2p. So we have here 1 plus p minus 1 into 2 to the power p plus p plus 1 into 2 to the power p. What is the common factor between these two? Common factor is going to be 2 to the power p, right? Okay, 2 to the power p is the common factor. So I am taking 2 to the power p is a common factor. Then inside the bracket I have p plus 1 plus p minus 1. So minus 1 plus 1 cancel. I have 1 plus p plus I have 1 plus 2p into 2 to the power p, 2 to the power p. So I give 2 here. If I give 2 here, we know if we have a same base, we can add the power. So p should be here 2 to the power p plus 1, that we can have. So I can make p instead of this part, right? Instead of this part. So instead of p, here instead of p, I can make p plus 1 minus 1. So plus 1 minus 1 cancel, the same part is remaining. So 1 plus bracket p plus 1 minus 1 into 2 to the power p plus 1. Now tell me, this is the same result, that I have here, right? So this result is also true for n equals to p plus 1, n equals to p plus 1. Now tell me, what is the conclusion that you are going to write here? What is the conclusion? How am I going to write the conclusion here? We have proved that this result is true for n equals to 1, the least number that n can take. Here consider, we have made the assumption that this summation up to p is equal to this part. By the summation, now I have proved this part is true for n equals to p plus 1. Now what should be the final conclusion that I can give? We have proved this result is true for n equals to 1. If for n equals to 1, p plus 1, if the result is true, the result is also true for n equals to p. By this principle of mathematical induction, we can say this part is equal to that part for all n belongs to Z plus. This is the way that we are solving the principle of mathematical problem, right? So there are a lot of questions you might be studied, right? You must be studied, but that you want to know what are the steps that you are going through, what are the steps that you are going to implement in this question. That is very important. Okay.